Hello YouTube viewers, welcome back to my channel. I'm Street Tips. Today what I have is a small quantity here of karat gold. It's all going to be 14 karat gold jewelry items with some stones in them, some diamonds and other stones, and we're going to demonstrate how to remove that stuff and get the gold ready to be refined. And then I'm going to refine it and cast it into a nice little ingot, stamp it, and put it up for sale on my eBay store. And before we go any further, I'd like to take a moment to thank all of those folks who have donated to my PayPal account. That's greatly appreciated. I appreciate those donations, and they go a long way to helping me keep my YouTube channel going. So without any further delay, let's get right to it right now. Alright, to get started here, let's take a look at these jewelry items that I have. This is a 14K gold ring that I bought at the thrift store. It was 20 bucks. There's no marking inside the ring. And the way that I could tell that this was a 14K gold ring is I looked at the little prong down here. I don't know if you can see that on the camera or not. Right down here on this bottom diamond, the prong has been worn away. And if this was a piece of costume or piece of silver jewelry, that prong would look much different. It would be a silver color, but I could see that the gold has worn that, or over time the prong has been worn away. That's how I was able to tell that this was a 14K gold ring. Alright, I've got a diamond tester here. I'm going to try to get it on one of these stones so you can see that it is in fact a diamond. It sends the tester up into the diamond range. That's what we want to see. That tells me that I've got diamonds in this ring and not CZs, so I'm going to remove these diamonds and save them now. These are my diamonds that I save. I've got them in little boxes here that are indexed, or not indexed, marked with little graphics there to kind of help you measure the size of the diamond. These are all diamonds. These have all been tested and verified. And what I'm going to do here is open this up. And it's got a little sticky surface here, and the diamond sticks to that surface and stays adhered. And what I'm going to do is take my pair of cutters here, and I bent the prong back there. You can see that. And I bent the other prong, and then I'm just going to go ahead and flick it off into the container there. Hope you're able to see that. Just bend the prong back, and then bend another prong back. That'll loosen the stone up, and then I can just kind of kick it out of the ring down into the diamond container there. And that's how you take them stones out. I've got another piece here that's got about 1.5 millimeter diamonds in it all the way around. I'm just going to verify that with the diamond tester here. And yes, they are diamonds. And if you notice this piece, it's a nice piece here. It's small. It only weighs probably a gram, gram and a half. But if I tried to sell this on my eBay store, I'd get less than 100 bucks for it right now. On the other hand, each of these diamonds I could sell to customers at the diamond or at the jewelry repair store where I work for about $15 each. So it's more beneficial for me to go ahead and take these diamonds out and save them for use in customers' rings. They'll lose a stone out of there, and then they come into the shop, and I use these diamonds to replace the diamonds that customers lose out of their jewelry. Alright, these are 2.2 millimeter diamonds. I think I got 3 of them in there with some blue sapphires. And they are diamonds, as you can see there. This ring weighs about 2.5 grams. I'd be lucky to get $100 for it on my eBay store. But I can sell each of those diamonds for about $75 each. So rather than try to sell the ring, I'm going to go ahead and pull these diamonds out of here and save them to be used to replace diamonds that customers lose out of their jewelry. I'll get those blue sapphires out of there in a minute. I don't want those in my diamonds. Anyway, there's the diamonds removed out of the ring. Believe me, I couldn't get $225 for this ring. No way. I'll make more money selling the diamonds to a customer who needs a diamond replaced in their ring. Alright, here I have a chain that's got a clasp on it, and what I do with these, I save these. Even though this one's not suitable to be reused, it's kind of worn out a little bit, but I save these as kind of a little savings account for myself. This is all 14 and 10K gold catches, and I just add those in and save them. Alright, now we'll get a weight on the 14K gold scrap that we have here. All the stones and non-gold material has been removed. We've got 22.5 grams of 14K. Transfer that into a little melt dish here. And we've got 22.5 grams. 14K. We're going to multiply that by 1.265. So we got 22.5 times 1.265 equals, we need 28.4 grams of silver to add to this gold to get a 25% gold alloy. So I need 28.4 grams of silver. I calculated I needed 28.4 grams of silver. I've got 28 grams here of sterling silver, 925 sterling silver. That's close enough. It's better to add just a little less than a little more. So now I'm going to add the silver to the gold in the melt dish. I'm going to take it out and melt this up and stir it with a graphite rod to make a 25% gold alloy, so that we can use hot dilute nitric acid to remove the silver and the base metals. It's called inquarting. I'm going to take the crucible now, put it down on the melt table here, melt the gold and the silver to make an alloy of gold and silver, 25% gold. There are those who are not familiar with the refining process here, who will be asking, why is he adding silver to that 14K gold? The answer is, it's a refining technique called inquartation. We add enough additional silver to that 14K gold to get the gold concentration down around 25%. With the gold concentration this low, we can then use hot dilute nitric acid treatments to remove the silver that we've added, plus all the silver and the base metals that are already alloyed with the 14K gold. When I get done with these hot dilute nitric acid treatments in the next step, the remaining gold will be nearly 3/9 fine. That's how effective in quarting the gold and then parting out the silver and the base metals with hot dilute nitric acid is at cleaning this gold. It is a very valuable refining technique, one that I learned early in the process. It was taught to me by some professional refiners. This is the process that they use to remove the silver and the base metals out of the gold before we go to the aqua regia. Next, I pour the 25% gold alloy into a metal container of tap water. It's important to use a metal container here because plastic or glass could fail. Take this in, pour off the water, get it into a beaker, and then get it in some hot dilute nitric acid. Alright, now what we're going to do is get the gold out of this metal container and into a beaker. I'm going to rinse it out real good with some distilled water. We're using distilled water to rinse the gold off with because we'll be using nitric acid to dissolve out the silver. Tap water contains chlorine, and it will cause silver chloride to form in our solution, and that's something that we want to try to avoid. I'm going to rinse this real good with several rinses of distilled water. And then we're going to put it on some heat with some dilute nitric acid on it. I should do it. That's what our gold looks like. Got our gold in this beaker right here. Here I have some used dilute nitric acid from a previous refining. I'm going to use this to start dissolving out the base metals and the silver out of this inquarted gold now. I'm going to cover this up. We'll put it up here on the heat and let that nitric acid do its job. This is the first hot dilute nitric acid treatment. It's been on here boiling now for about 45 minutes. What I'm going to do is dump off the solution that's going to contain silver into this jar right here and save it. Give it a quick rinse with distilled water. Now I'm going to add some more dilute nitric acid to the gold and do a second dilute nitric acid treatment. This will be treatment number 2. Nitric acid treatment number 2 is complete. Now what we're going to do is pour this solution off into my silver jar over here. There will be some excess nitric acid in this blue solution that I'm pouring off into my silver jar. Plus there'll be some silver in that liquid, and I'll recover that later on. All we do is add some additional sterling silver to this jar here, this one here, to consume any excess nitric that's in the solution, and then filter it and cement all the silver out on copper. Alright, this is hot dilute nitric acid treatment number 3 going in right now. Gold has been under this third dilute nitric acid treatment now for about 10 minutes. Just now beginning to boil. As you can see, the color of the liquid has turned a tint of green, and there's still fumes inside the beaker there, which tells me that there's still silver and other base metals that are reacting with the hot dilute nitric acid on this third dilute nitric acid treatment. This is the third hot dilute nitric treatment. It's been on boiling now for about 45 minutes. You can see the fumes have cleared up in there pretty much. The solution is a light blue color, so what we're going to do here is we're going to take and put this in our used nitric bottle, and we'll reuse the acid that's in this beaker right here for our next batch of carat gold that we refine. This is still going to have good active nitric acid in it, so I'm going to save this. See the brown pieces of carat gold in there now, looking pretty good. I'll rinse this out and add the rinse water to my silver jar over here. And now what I'll do is I'm going to put this back on the heat. I'm going to add distilled water to about the 100 milliliter level. Now I'm going to add about 100 milliliters of concentrated nitric acid here. Cover this up. This will be our 4th hot dilute nitric acid boil, and we'll let this boil. The goal here is to get that gold completely void of any silver or base metals with these hot dilute nitric acid treatments. And I can tell when all of the base metals and silver has been dissolved, when the atmosphere in here stays clear and the color of the solution remains clear. Okay, as a demonstration here to show why it is important to add silver to the 14K gold in order to allow the nitric acid treatments to be able to do their job. This is my 14K gold wedding band here. What I'm going to do is I'm going to add this into the beaker here to show you that the hot dilute nitric acid, boiling nitric acid in this beaker will have little, if any, effect on the 14K gold as it is. Here it goes. I'm just going to leave that in there and let this boil for a little while. My ring has been in there boiling in the nitric acid now for about 5 minutes. I'm going to reach in there and get it out and dunk it in some distilled water here. And the point of this little demonstration is to show that the nitric acid cannot penetrate into the 14K gold until additional silver is alloyed in with it. Then and only then will the hot dilute nitric acid treatments be able to get all the silver out plus all of the other base metals. Remember that the brown material left in that beaker was 14K gold when we started. We added silver to it to get the gold content down to around 25%. And then we've done 1, 2, 3, 4 hot dilute nitric acid treatments on it to remove the silver and the base metals. The process is complete now. I can tell because the atmosphere inside the beaker is clear. The solution is clear. There's no color to it. That means that the gold left in that beaker right now is very close to 3/9 fine, just like it is. No further treatment is required. Alright, I just want to reach in here and show you my ring. It's got a little bit of discoloration on it, but that'll all buff up real good and it'll get restored to just like new condition after I run it through the buffer, clean it up. The point is, the hot dilute nitric acid won't touch the base metals and silver in this 14K gold until after it's been alloyed with additional silver. Alright, we've got this 4th nitric acid treatment here. The atmosphere in there is clear. The solution remains clear. That means that that gold has been completely cleaned of all the silver and base metals. And one more time, just to reinforce the importance of encording the gold with silver, if I just put the 14K gold in this beaker and added the hot dilute nitric acid to it, nothing would happen. As you've seen with my wedding band that I threw in there. Only after I alloyed the additional silver in here, then and only then will those hot dilute nitric acid treatments have any effect on removing the base metals and silver that are in the 14K gold alloy. Alright, I've got this cleaned up nicely. You can see the gold is a nice caramel brown color. Looks real good. It's ready for refining with aqua regia. What I'm going to do is I'm going to set it back on the heat over here. I'm going to add some hydrochloric acid here, and we're going to start dissolving this gold with aqua regia. Get down on there, get the right angle here for the camera. Should get an immediate reaction because there will be some residual nitric acid left on the gold. Before I go any further, I'm going to take and add a little bit of concentrated sulfuric acid here. What this will do, it's about ½ ml. That will precipitate any lead that's in there, forming lead sulfate, and then I can 100% filter out any of the lead sulfate. It'll remove all of the lead out of the gold. Okay, I'm going to start adding small doses of concentrated nitric acid here. I'm going to start out with about 3 milliliters concentrated nitric acid going in right now. I've got 3 milliliters of concentrated nitric in there so far. I'm going to try to add another, what is that, 2 milliliters going in now. Let's see if I get the camera angle right here. I'm just going to put this in real slow because it's hot. You can see just a couple drops sets it off into a very vigorous reaction. Just add it real slow because I got the solution real hot here. Alright, there we go. We got the 2 more milliliters of concentrated nitric acid. So we got a total of 5 in there now. Gold has been in there now for about 15 minutes. I'm going to put in another 1 ml. It's almost completely dissolved. I've got 5 in there right now. I'm putting in another 1 ml. 1 milliliter of concentrated nitric acid to get the rest of the gold to dissolve. So I've got 3, 2, 1. I've got 6 milliliters of concentrated nitric in there now. Alright, it's taken about ½ an hour. 6 milliliters of concentrated nitric acid with 100 milliliters of hydrochloric acid. I'm going to take it down off the heat now. I'm going to let the solution cool, and then we'll run it through a filter and precipitate out the pure gold. Get a quick temp on the solution here. It's at 179 Fahrenheit, 81.8 Celsius. I'm going to add some ice cubes to cool the solution down. The ice cubes are made from tap water. The tap water around here contamination is measured in parts per million. That's not enough to register in an assay on my gold here. It's got chlorine in it, theoretically, but we're dealing with a chloride here anyway, so it doesn't make any difference. Tap water ice cubes going in to cool the solution. Okay, I've got everything chilled here, including the flask and the funnel. Got the solution cooled down to 10 degrees Celsius, 50 degrees Fahrenheit. The reason we're cooling it all down is to, the main contaminant here is going to be silver chloride. I've even chilled the distilled water in the freezer before I got started here. And what we want to do is get the silver chloride out of this solution. Silver chloride is somewhat soluble, but it's less soluble in a cold solution. So now we're just going to go ahead and filter the solution here. Once we get it filtered, we'll transfer it into a clean beaker and precipitate out the pure gold. Go ahead and transfer the solution now to this clean beaker. Get rid of the funnel here. Pour our solution in this clean beaker. Okay, here we go. First precipitation. Use sodium metabisulfite here. Just going to spoon it in and precipitate the gold. That should do it. Here's our gold. I allowed it to settle overnight. The color of the solution sitting on top of the gold is crystal clear, colorless. If that solution is yellow, green, or blue, that's a good indication that there's going to be some contamination in the solution, and therefore in the granules of gold down at the bottom of the beaker. Now what I'm going to do is pour that solution off, and we'll give it a rinse with hydrochloric acid. I'm going to pour the solution off into my stock pot. The stock pot has copper in it, and it will cement out any residual precious metals that may be in the solution. A little bit of gold might go over with the pour here, but that's okay. We'll recover the gold out of there later on. I'm going to rinse the gold with some hydrochloric acid here. Pour that hydrochloric acid rinse my stock pot as well. Now what we'll do is we'll get the gold into a filter and redissolve it. Rinse it one more time with a little hydrochloric acid here. Just a dash. And I've got a filter set up here. What I'll do is I'll pour this gold through the filter now and collect it into that filter. Rinse it with a little distilled water here. Transferring the gold with the filter paper right back into the beaker here. And then I'm going to add about 100 milliliters of hydrochloric acid here. I'm going to add a few drops of sulfuric acid just to make sure that we've got all the gold out. Adding the sulfuric acid here hurts nothing. Provides a nice benefit in that if there's any lead that's in here at all, it'll get precipitated out with this sulfuric acid. Next I'm going to add nitric acid. It took 6 milliliters of nitric acid in the previous refining. So this one, I'm just going to go ahead and put 6 in right now. Okay, there's 6 milliliters concentrated nitric acid. What we'll do now, put it up on the heat and let it dissolve this second time. This second refining really cleans the gold up nicely. Well, it took about 6 or 8 minutes for this gold to dissolve. You can see that the filter paper has completely disintegrated. Got everything in solution. So I'm going to pull this down off the heat there. Let it cool so we can get a precipitation for the second time. I'm adding ice cubes here. These are made from tap water. Just going to throw them into the solution and cool it off so we can do the precipitation. Now we're going to filter out the disintegrated piece of filter paper in there and any other contamination that might have found its way in there. Still got a few pieces of ice in there.
rinse all the color out of the filter here. Get the funnel out of here, transfer the solution to our beaker. Nice and clear. Now we're going to add some sodium metabisulfite here and precipitate out pure gold a second time. Should just take 2 spoons, that's what it took on the first refining. Should do it. I've allowed the gold to settle now for a couple of hours. What we're going to do is pour off our solution now into my temporary stock pot. A little bit of gold to go over with it, but that's okay. We'll recover this later on. Now I'm going to take a little bit of hydrochloric acid here, and we're going to give it a couple of rinses with some hydrochloric acid. Get all the sodium metabisulfite rinsed out of it there. Gold's turned a different color now. It's a lot more light brown colored. Give it one more rinse here. See, the color of the gold is nice and brown. Looks good. Settles quickly. I think what I'm going to do is redissolve it one more time. Precipitate one more time. Looks kind of a darker brown color that I like to see. Don't look too bad. But I'm going to dissolve it and precipitate it one more time, just to get it cleaned up the best that I can. hydrochloric acid, about 100 milliliters. We put in a little bit of sulfuric acid here, just in case we still got some lead present. Shouldn't have any, but I'm going to put a little in anyway, just to make sure. And then we're going to go ahead and add some nitric acid, form aqua regia in there, and redissolve the gold a third time. Concentrated nitric acid going in. It's about 1.5, 3. That's about 4.5 milliliters concentrated nitric acid going in. Alright, it took about 10 minutes to dissolve there. Pull down off the heat. And add a couple of ice cubes here. The ice cubes are made from tap water again. Got a filter paper in here. Going to filter it for the third time now. Transfer the solution into a clean beaker here. Into the funnel. Solution's nice and clear now. No traces of cloudiness. Now we're going to precipitate for the third time with some sodium metabisulfite. Hopefully we'll be able to get this into a melt dish after this precipitation and melt it up into an ingot. That should do it. One more maybe. Yeah, looks pretty good. Alright, this has been allowed to settle now for about half an hour. I'm going to pour off the waste solution, and then we're going to rinse it a couple times with some hydrochloric acid, and then we're going to get this into a melt dish and melt it into a nice little ingot. Get all that SMB rinsed off of there. We'll just do these rinses until the solution is nice and clear. It's looking pretty good there. Give it a quick rinse here with some distilled water. And there's our nice pure gold powder. All right, now we're going to coax the gold down into this melt dish here. Like that. And I'm going to drain out the water here. And we'll take it over to the melt table and melt it up into a nice ingot. Alright, we're going to go ahead and melt the gold into a nice ingot here. Alright, here's our little gold ingot. And as you can see, there's a little bit of contamination on the surface there. I don't know what that is. This is one of them refinings that some stuff followed the gold through the entire process, through all three refinings, and shows up as contamination on the surface of the ingot. Here's our little gold ingot. It's got a little bit of contamination on the surface there. Some materials in there that followed the gold through all three of the refinings. And I originally made this video to be a nice, short, and sweet little video on how to refine a few pieces of 14K into an ingot, and it's turned into a long, drawn-out process here. But I'm not going to give up. I'm going to go ahead and we're going to try to precipitate this with some oxalic acid now. So I'm putting it into a beaker here. I'm going to add some hydrochloric acid, about 500 milliliters or 100 milliliters. And then what I'm going to do is redissolve this piece. And we're going to use a different precipitant, use oxalic acid, to see if we can get all that contamination out of there. As always, I'm going to add a little bit of sulfuric acid here, just a smidgen, to precipitate out any lead that might be present. And now I'll add concentrated nitric acid here. We'll dissolve that pure gold ingot a fourth time here. And then I'm going to re-precipitate this time with some oxalic acid and see if we can get all the contamination that's following that gold out of there. Our gold has been boiling in aqua regia now for about an hour. What I'm going to do now is you can see there that some of the hydrochloric acid has boiled off. So I'm going to add a little bit of hydrochloric acid here, about 60 milliliters. I'm going to pour that right in. And now I'm going to add about another 3 milliliters of concentrated nitric acid, and let this continue until all that gold dissolves completely. Sorry, I just had to throw this in here. I happened to be looking out the window and seen this amazing red-headed woodpecker. The thing was about as big as a chicken. Had this on the heat now for about 2 hours. I've probably got about 15 milliliters of concentrated nitric in there now. And we'll just let this keep going until that ingot dissolves completely. While I'm waiting for our gold to dissolve, I'm going to go ahead and mix up some oxalic acid here. And this is oxalic acid from Ace Hardware. It's called wood bleach. It's oxalic acid. What I'm going to do is measure out about 30 grams or so. This is only a ½ ounce of gold. So there's about 32.6 grams. I'm going to set this up here on the stir plate here. I'll turn this scale off. I'm going to add some distilled water. About 100 milliliters to our oxalic acid here. That's about 150 milliliters. Got a magnetic stir bar here. Turn some heat on and start stirring our solution. Get that oxalic acid to dissolve. This is page 172. Out of C.M. Hoke's book called Refining Precious Metals Wastes. Down here at the bottom it says, in general, do not use the same precipitant for repurification. Sulfur dioxide, which is the same as SMB, tends to carry down traces of platinum group metals with the gold. Oxalic acid does not. I think that there's some palladium possibly in with my gold, and it's precipitating out when I put the SMB in there. Oxalic acid does tend to carry down tin and copper, but sulfur dioxide does not. This is the reason you want to use 2 different precipitants. Getting rid of the platinum group metals is the reason I've chosen to use oxalic acid for this 4th refining. This is page 173 of the same book. It describes the procedure for precipitating the gold with oxalic acid. It says for each troy ounce of gold you need an ounce of oxalic acid crystals. Dissolve the oxalic acid in hot water. It says to add a little bit of ammonia. Don't add too much ammonia. If you do, you're going to have to put some more oxalic acid back in there. Use a piece of litmus paper or pH test strip to check the pH of the oxalic acid. Boil both solutions. Both solutions have to be boiling in order for this to work. It says they prefer to pour the gold solution into the oxalic acid solution. I prefer to do it the other way. I put the oxalic acid in the gold. It says there will be bubbles and fumes, so work slowly or the liquids may boil over. If you fail to expel all the excess nitric, then brown fumes will appear. If this happens, you may have to add more oxalic acid. Let the mixture stand for a time. Keeping it hot if possible. The gold comes down as bright, clean crystals, often very beautiful, which settle very promptly. I've got a filter prepared here in a funnel. The oxalic acid solution has dissolved completely. Only took about 5 minutes. And I'm going to filter the solution now just to get any junk out of there. And then we'll pour the solution from the flask back into the beaker. And when the time comes to precipitate the gold, we'll start to heat back up and get this stuff boiling. We'll keep our gold solution in the back boiling, then we'll add the two together and precipitate out the pure gold with the oxalic acid. Get the funnel out of the way. That only took a minute. And we'll pour the solution back into our rinsed beaker. And then I'm going to set it up here on the heat and just let it stay hot. I just added a little bit more hydrochloric acid. You can see what the piece of gold's looking like now. It's probably about half dissolved. Been in there about 3 hours now. Gonna put a little more nitric in here now. I think I got about 20 or 25 millimeters of nitric acid so far in there. Stark contrast between trying to dissolve a piece of solid metal and the powder. The powder dissolves with 6 milliliters of nitric in about 10 minutes. This has been on 3 hours. It's taken 25 milliliters of nitric acid and it still hasn't dissolved. Okay, we started this at 2:45 p.m. It is now 8:15. This is about 60 milliliters of hydrochloric going back in. This has been on about 5.5 hours. That's nitric. You can see a little piece of gold down there. Still, got a little ways to go. I've probably got about, this will be 28 milliliters of concentrated nitric that I've added so far. It's been on there for about 7 hours now. I've got the heat cranked up pretty good. There's just a thin wafer of gold left in there. You can see it's dancing around in the beaker. That means we're real close to having that thing completely dissolved now. It took 7 hours. Alright, the time is 11 p.m. and this took about 8 hours to get the gold to go into solution. Now I'm doing the classic evaporation down to a syrup, and then I'll expel excess nitric with some hydrochloric acid. And once we get all the nitric out of there, I'll cool it off and filter it. Then we'll put it back on, get it boiling, add the oxalic acid, and get it precipitated. I've got this evaporated down to a syrup now. You can see it's kind of a thick consistency here. And what we're going to do is add hydrochloric acid and try to expel any excess nitric acid that might be present. We would normally do this with the lid off. I'm going to leave the lid on so we can see if there's any red fumes that evolve when I add this hydrochloric acid. And I didn't see anything. I didn't see any fumes form inside there. So I'm thinking that we're free of nitric, free of excess nitric here. I'm going to go ahead and shut this off now, and we'll let it cool down, filter it, and then do the precipitation with oxalic acid. I'm going to add some ice to the solution now to cool it down. and then we'll get it filtered and get it boiling again so we can do the precipitation with the oxalic acid here. I got a number 3 filter paper in here, slow flow. The solution's been cooled down real good now. So what we'll do is pour it through our filter paper here. Alright, we got it all filtered out. I'm going to transfer the solution over here into a clean beaker. So we can get the camera angle right here. I've got both solutions boiling now. What I'm going to do is add a clean stir bar to my gold here. And then, because what I'm going to do is I'm going to swap these two. I'm going to pour the oxalic acid into the gold solution. I want the gold solution on the stir plate. What I'm going to do first here is get a baseline with a pH test strip here of our oxalic acid solution. You can see we got a bright red pH of 1. Next I have some 10% ammonia here. I hate using ammonia. It seems like to me that it is the most corrosive compound that I've ever have to work with, and I hate working with it, but that's what the book calls for. So here we go. We're going to dose the oxalic acid here with a little bit of ammonia. Let that come back to the boil and we'll check it with a pH test strip. I had to add nearly 100 ml of ammonia to my solution here. I got the pH around 3. That should be good enough for this experiment. Okay, both solutions are boiling. I'm going to trade these. I'm going to pour the oxalic acid into the gold. Let these heat back up, and then we'll do it. Okay, here goes nothing. I'm going to pour the boiling oxalic acid solution into the gold solution. Let's see if we can get this gold to precipitate now with the oxalic acid. Here we go. Yeah, something come out of solution there. Chunks of gold precipitating. Pretty cool looking. Yeah, I can see hunks of gold floating around down to the bottom there. Let this boil for a while. See if we can get all this to precipitate. There's a shot of the pure gold sponge that's forming in the bottom of the beaker there. bit more of the oxalic acid solution. It's clearing up. The solution is becoming lighter and lighter. Just want to make sure I have an excess of oxalic acid in there. Get everything to come out of solution. This is going to probably boil up pretty good here. It's been about 10 minutes since I added the oxalic acid. I'm going to try pouring just a dab of ammonia straight into this solution here and see what happens. Just a little bit. That does seem to lighten the solution up a little bit. Been on here boiling now for about 25 minutes. The solution is completely cleared up. Do a stannous test here. And as you can see, we got no gold in solution. Everything's been precipitated now. This is our pure gold sponge. Get a close up of that there. It's going to be some ultra high purity gold here. Going to turn our heat off now and pull it down off the heat, let it cool off. Here's our gold sponge. And it really does look like a sponge. Going to give this a couple of rinses with some hydrochloric acid. First, I want to get the stir bar out of there. And we're going to pour off the waste solution into this flask here. Actually, first let's rinse the particles of gold down off the side of the beaker there. Some of them might go over and into the waste container here, but that's just fine. We'll get it out of there later. Here's our pure gold sponge. Nice and brown, light brown color, which is what we want to see. Now what I'll do, I'm going to put a little bit of hydrochloric acid on here and rinse it off a little bit. Pour that right into the jug, the waste container. Give it another real quick rinse here with some hydrochloric acid. See if I can get most of them chemicals rinsed off of there before we go to the melt dish. Stuff looks super, man. Nice and brown. Light tan brown color, which is what I was looking for earlier and couldn't seem to get. With the SMB precipitations, there should be some high purity gold here. Alright, let's get this into a melt dish and get this melted into an ingot. I've prepared a freshly glazed, brand new melt dish to eliminate any possibility of contamination getting in there from a dirty melt dish. Now we're going to get the gold down into the melt dish here. And now I'll use a little dropper, the transfer pipette here, to get the water out of here. Transfer the melt dish with the gold sponge in it over here to the melt table. Go ahead and start the torch up. Start melting the gold now. All that contamination has been removed with the oxalic acid precipitation. We're going to do it, put it up here on a scale. Let's see what kind of yield we got here. We got 13.1 grams of pure gold. Going to stamp 3 tips on it now. And we're going to put 999 on it. Make sure don't mess this up and put it upside down or something. The word fine. And finally the word gold. Okay, here's our finished product. It says 999 fine gold 3 tips on the front of the ingot. And then on the back, I've stamped the weight, 13.1 grams. This will conclude the video. I've got a nice little ingot of gold here. And what we'll do is we'll get this pictured up and get it listed on my eBay store. My eBay store name has changed from Baffless to my YouTube username, which is 3 tips. My eBay store is now called 3 tips to match my YouTube channel. And we'll sell this little ingot. It weighs 13.1 grams. I've got my name stamped on it, 999 fine gold on the front, and then on the back I put 13.1 grams of pure 24K pure gold. And that'll conclude the video, but I'd like to say thank you to all those folks who have seen their way to make a donation to my PayPal account. That helps a lot. It might help me pay the light bill or a water bill or whatever. And
aid me in continuing to produce these precious metals refining videos. That'll conclude the video. Thanks for watching.